Here's a few MyMathLab examples for you. We're being asked in number one to solve the exponential equation, and notice it tells us express each side as a power of the same base. And the equation I'm given to work with in this case is 4 to the x power equals 16. I go to the larger number, the 16, and I try to write it as a power of the base on the other side, which is a 4. Is 16 a power of 4? Sure, it's 4 squared. Leave the left-hand side the same. Once you have the bases the same, you can ignore them, set the exponents equal to each other, and we know x equals 2. Now in this case, they want the answer as a solution set. So you're going to see these set brackets, and you would just put your number inside. Let's do another example where you are expressing each side as a power of the same base. This time I have the equation 2 to the 3 minus x power equals a fraction 1/8. Now what I want you to remember about fractions is that they are the result of a negative exponent being applied to a base. So you want to begin the same way, except instead of looking at this whole side and trying to write it as a power of a base, you want to just examine what you have in the denominator and consider writing that as a power of, hopefully, the base you have on the other side. Is 8 a power of 2? Well, we've got 2 to the first is 2, 2 to the second is 4, 2 cubed is 8. I'm going to leave my left-hand side alone. I'm going to write my right-hand side as 1 over 2 cubed. Now you need the negative exponent rule that says if you have x to the negative exponent, it's the same as 1 over that x with a positive exponent. So in my situation, I'm looking at 1 over 2 cubed, and I need to go back to writing it as just a single exponential expression. If you follow the pattern, this would have to be the same as 2 to the negative third power. So now that's how I will write the right-hand side. Once my bases are the same, ignore them, set the exponents equal to each other. And you'll notice here I have minus x. I need to solve for x, and this subtracting x generally makes students uncomfortable because if I move this 3 away from it, I'm still stuck with that negative sign on the x. So the easiest way to correct this is do the opposite operation and add x to both sides. Then my equation becomes 3 equals, and on this side I could write this as negative 3 plus x. I can also reverse the order and put the positive x, or just x, first, then the minus 3 after. And now you can see this is a simpler equation to deal with. I'm still trying to get x by itself, so in this case I would add 3, and my answer is that x equals 6. This next problem says to solve the equation, but we've got different directions. It says express the solution set in terms of natural logs or common logs. Then use a calculator to obtain a decimal approximation for the solution. So my equation is 2e to the 2x equals 262. And I'm not going to try and get the same base on both sides because with a base of e, which is a decimal to begin with, that would be a nightmare. Before I can take the log of both sides, I have to remember to isolate my exponential expression. Right now, I have a base and an exponent, but there is something on the same side of the equation. There's a 2, which is multiplying it. So before I'm ready to begin with my logs, I'm going to divide both sides by 2. This gives me e to the 2x equals 131. Now I'm ready to introduce the logs. And particularly when you see a base of e, natural logs should be the automatic choice. So I put the natural log on the left, and I put the natural log on the right. The purpose of introducing the logs is to be able to use the power rule and take that exponent where the x is, bring it down in front, multiplying the log. So now I have 2x times natural log of e equals natural log of 131. Now this natural log of e, when your base matches your log, you want to stop to check if that can be reduced. So what is natural log of e equal to? If you go back to the exponential version of this, remember the base of the natural log is e to some exponent has to equal what's inside the parentheses, which is e. And hopefully you can see that this expression has to be equal to 1. So natural log of e, I'm going to change to 1. I now have 2x times 1 on the left, which is just the same as 2x, equals natural log of 131. Finish solving for x by getting rid of the coefficient of 2 by dividing. This is the first answer that MyMathLab wants you to put in. They want the solution set expressed in terms of logarithms, and it should be simplified like we did, where we changed one of the logs to just a whole number. You want to take care of any of that simplification that can happen. So inside these set brackets, I would put ln 131 over 2. You're going to need to use your math palette to access the symbols for that. Then we're asked to use the calculator to get the decimal approximation. I'm going to be sure to use my ln key, my natural log key. And this time you'll see that MyMathLab does ask for 2 decimal places as needed. So I'm going to round this to 2.4. You look to the next place past the 3, it's a 7, so you round up. So my answer will be 2.44. And here's one last example. Solve the exponential equation, but again, we're asked to express the solution set in terms of natural or common logs. So we're going to be taking the log of both sides to accomplish this. Now, in this exponential equation, remember the first step is you have to isolate the exponent and base. So over here on the left, I have a base, I have an exponent, and then I have this -5 just hanging out. We need to move that to the other side before we introduce logs. Once you have your base and exponent isolated, you introduce the log, and certainly again, if I see an e, my log of choice is going to be the natural log. The purpose of introducing the log is to be able to bring that exponent down in front. Now this exponent happens to be a binomial, and you're going to want to be careful and keep that in its own set of parentheses to make it clear that whole thing is multiplying natural log of e. So hopefully by now you have started to memorize some basic log facts. The natural log of e is 1. The common log of 10 is also 1. In this case, I do have natural log of e, so I'm going to let that become 1. This gives me 3x minus 7 times 1 equals the natural log of 29,249. Multiplying by 1 doesn't change anything, so really I just have 3x minus 7 equals natural log. And now I would do my equation solving procedures. So I would add 7 first, then I'm going to divide by 3. Now an important note here, do not just add the 7 to the numbers inside the parentheses because there's a log out in front. So I just need to express this as natural log 29249 with the plus 7 hanging on to it. So I have x equals, And the logarithmic form of my answer would be this. So that would go inside my solution set brackets. Next, I will go ahead and put that into the calculator. Now in this case, I have a binomial in my numerator. I have one quantity plus another quantity. And again, for the sake of being careful, I'm going to introduce parentheses around that whole numerator. It's good practice anytime you have a binomial in a fraction, either numerator or denominator. Then my division sign, and I'm again being asked to round to 2 decimal places, so this one will be 5.76. Okay, hopefully you are now ready to try a few.